In this video, we will discuss fields and properties data members of a C# class. Let's review some terminology here. When we are talking about a class, when we refer to a field, we are talking about a variable defined in a class. So a field is just a variable that is defined inside the class code block. A property looks similar to a variable, but a property is a data member that allows protected read-write access to a field variable. And we will see this in action in a couple minutes. Now we have three access modifiers we will be talking about and using. Public and private. The public and private access modifiers describe who has access to the data member. A public data member is accessible both inside the class and outside the class. A private data member is only accessible inside the class. And then the static access modifier describes how a data member is accessed. A static data member is accessed from the class. A non-static data member is accessed from an object built from the class. All right, when would we use a field variable? Well, if we were building a class to function as a library of static methods, a field could be a variable that holds persistent data across multiple method calls. So what are some examples of this? Well, when we use the console class has some values that you can save inside the console class. For example, you can save the title value of the console, the foreground and background color, the width and height of the window, the console window itself, etc. So all of these values are values that we can change. We can set the value of the title or the foreground color of the class, and then as we are printing and operating with the against the console, these values persist across multiple method calls. So if I change the foreground color in my console class, everything I print, every time I call the WriteLine method, I'm printing with this new color. So we are saving a value to the class. If we were building a class that would function as a blueprint for building objects, then field variables hold attribute values, attributes of the object we are modeling. So what does that mean? Well, let's say we wanted to build a class that would represent a circle. We want to model a circle in our program. Well, a circle has a radius, so maybe we could create a field variable that would hold the circle's radius. If we were building a class that would model a car, we could have several field variables. We could have a field variable that would hold the make of the car, the model of the car, year, color, number of cup holders, etc. So in a non-static class, fields will hold the data, the attribute values for the object. When would we use properties? Well, if I created a field variable in my class, whether it's static or not, if I created a field variable and made it public, that means the outside world has direct access to this variable and they can assign any values into it. But what if the outside world assigns a bad value? So for example, let's say we created a person class and we wanted to have a field that would hold the person's age. If we made this age field variable public, then the outside world, a program for example, could write the value negative 1,000 to the person's age. And a negative 1,000 age doesn't make sense. It kind of breaks the integrity of what we are trying to model. So instead of just making the field variable public, we are going to create a pass-through, a protection, through a property. So a property is going to stand between the field variable and the outside world. So in this case, we would make the field variable private, and then inside our property, we would create some logic rules that restricted the access to the field variable. So when the outside world wanted to, for example, assign a new age to our person object, they would have to go through the property, and the property would decide, is this value a good value to assign to the field variable, or will I block it? Okay, so a property behaves like a variable because the outside world will interact with the property like it was a variable, but the property doesn't really hold anything. It's just the pass-through to the field variable. Let's look at some syntax here. The syntax to create field variables are very similar to just creating a generic variable. So to declare a variable, you would pair a data type with an identifier. Well, if I was going to define this variable in my class to make it a field variable, I would just pair a data type and an identifier inside my class code block. Now, we're going to add some access modifiers in front of this data member. We can make this field variable public or private, and we can decide, does this field variable belong to the class, therefore is it static, or does it belong to the object, which means we would leave the static out. So an example of a static field, for example, in a console class might look something like this. Private static console color, that's the data type, and then the variable name is color. In a non-static field example, if we were thinking about our car class and we wanted to have a variable that held the number of cup holders for our car, we could create a variable, int number of cup holders, and then assign it an access modifier, private in this example. This is a non-static data member. Convention has it that field variables should always be private. Okay, we're going to keep our variables protected and then provide properties that allow interaction with our field variables. And then also field variables should always be lowercase or camel case. So when you declare a field variable as a lowercase, when you name it with a lowercase identifier, it helps us distinguish between the properties, which are usually uppercase. Let's look at the syntax to build a property. Well, property on the header for a property looks very similar to the field variable. We're going to have an access modifier, public or private, decide whether the property belongs to the class or not. So we can define it as static or not. Then we have a data type and an identifier. Now in this case, convention has it that properties, we use the same name as the field variable we are protecting, we just capitalize it. So if I had a lowercase age field variable, I could create a property named capital age that would protect it. Now a property has a code block attached to it. We see the code block right here. And inside the property we are going to have two smaller code blocks, a get code block and a set code block. The get code block has all of the logic that defines if the outside world wants to retrieve the field variable value, what are we going to give the outside world? The set block defines write logic. So if the outside world is trying to assign a value through the property, what logic will we implement in here that protects the field variable? By convention, properties are usually public. We want the outside world to go through the properties to get to the field variables. Properties are the capitalized names of the fields, and properties will use the same data type as the field they are protecting. So if I have a property that is protecting an integer age, then my property value would have an integer data type as well. So let's try to see a couple examples of this in action. Now, continuing from our previous video, we added an example class to our project, and we created two simple methods. We created a static method named static hello that just prints hello to the console, and we created a non-static method named non-static hello that prints a line of text to the console. All right. What we are going to do is we will start off by adding some fields to this class. When you are creating data members, the order does not matter. I could create my fields below my methods, above my methods, in between my methods. All data members can be created in any order you want. I'm going to put the fields up top though. Alright, let's add a name to both a static name field and a non-static name field. So we're going to modify our methods so that when we say hello from the class, we are going to say hello from the name of the class instead of the class itself. So let's see if we can make this happen. So the first thing I'm going to do is I'm going to declare a variable, a static variable that belongs to the class. So I'm going to create a variable that holds a name. So I'm going to say string static name, just a variable inside the class block. But I need to add some access modifiers in front of this. This first name is going to be, I'm going to first make my field variable public so we can see how that looks. So I'm adding public, and then I'm going to add the access modifier static because I want this variable to belong to the class. And then I'm going to add another field. I'm going to create a public string non-static name, and this is going to be a field variable that belongs to the object. Static belongs to the class, non-static belongs to the object. Now I'm going to quickly modify my methods here so that we are going to say hello from the name of the class. So I'm going to insert my static name variable here, and in my static variable here, and I'm going to modify my non-static method to insert the non-static name value. Now something should be noted here. When I am calling this static method, notice that I am not passing in the static name value as an input parameter. If I wanted to build a generic method, I might require, I will require outside values to be passed into the method for the method to do its job. But because I'm using a data member of the class, because I declared this variable of the class, all other data members have direct access to all other data members of the class. Now, static data members have access to static data members. So if I try to insert the non-static variable name into my static method, they do not see each other. Likewise, if I try to stick the static name value into my non-static class, well, this works, and we'll discuss why this works in a moment. Okay. The reason we can't put the non-static name into a static method is because this name does not, the non-static name does not belong to the class. We have to first build an object of the class, and this method has no idea of how many objects or which object was built from the class. I don't know if that makes sense. So here I'm going to put the non-static or the static variable name in the static method and the non-static name in the non-static method. Okay, let's see what this looks like. When I go to my program class and I go to look into my example class itself, here's my example, my class is named example. When I use the dot notation, I can see all of the static elements of this class. So inside my example class, I have access to my public static hello method and my public static name method. So from the class, I can see my static data members, but I cannot see my non-static data members. So if I wanted to go to my static name and set it equal to Rogers, and then call from my class the static hello method, that's not the right method. I'm calling the static hello method. Let's see what this looks like. We should see that once I assigned a value into a variable of the class, a separate method, a separate static method of the class can use that value. So my method is saying hello from Rogers. So it used the value I assigned into the variable of the class. Let's look at the non-static example here. So to build a non-static, or to use our non-static data members, we have to use them from an object built from the class. So I'm going to say non-static build an object first. So we can say our object will be of type example, and I'm going to call this example object. And we are going to build a new object using this class. So this is called we're calling the default constructor. We will talk about default constructors in the next video. But I'm building an instance of our example class. Inside this example object, I should see all of my non-static data members. Here I see my non-static field and my non-static method. So I will take my non-static field, set it equal to Anna, and then from my example object, I will call the non-static hello method. And we can see the object is saying hello from its name. Again, static data members belong to the class. Non-static data members belong to an object built from the class. Now, what if we go here and I'm going to say, I'm going to set my name to nothing in both cases here. So here it says hello from the blank, hello from the blank. Well, because my field variables are publicly accessible, I can write any value into them. Okay, they're not protected. So if I wanted to prevent the outside world from setting in, for example, an empty string as a name, I need to add some protection in my class to prevent this from happening. Okay? So let's see if we can protect our fields through properties. So we're going to create some properties. Now the first thing I'm going to do is I'm going to go to my fields and we're going to make them private. We do not want the outside world to have direct access to our fields. If I go back to my program, once I've made these fields private, we should see that we get an error here. I cannot access the field variables anymore. They are private. Okay. Now let's create a property to protect each of these field variables. First, I'm going to make a static property to protect my static field variable. Properties will be public. This property will be a static property. It's going to have the same data type as the value it's protecting, and I'm going to name this property the capitalized version of the field variable. So my field variable is lowercase static name. My property that is protecting it is capitalized a static name. I'm attaching a code block to my property, and then I'm going to build a get block and a set block. Now the get block defines read access. If I want to retrieve the static name value through my property, the get block is going to tell me what do I return. Well, this property is going to return the lowercase static name. So we are returning the field. Now I could return any string value here. I could say return unknown, and then every time the outside world tried to access the name field variable, I would give them the value unknown. But we will play nice, and we will say, if you want to get the static name value out of my property, I will give you the static name field variable value. Now the set block is going to be a little bit different. We are going to be dealing with something that is the keyword value. And let's make a note here. The keyword value holds the external value trying to be set. So the value that is trying to be set into the field variable. So here we can add some protection. I can say if the value coming in is not equal to an empty string, then I am going to set into my static name field variable the value. So let's look at this again. I'm testing the value coming in to the property, and if it is not an empty string, I will assign that external value into my field variable. So we are only writing values that are not empty. Now what might we do on the other hand? Well, maybe we will say, if you do not assign a valid name, I will say, let's do this. We'll say invalid name. So I am deciding that if you give me an empty string, I am going to assign the name invalid name into my field variable to try to make sure that it is not an empty string. Now you can do any type of protection you want. This is just an example of how a property can work. All right, let's do a non-static property. Non-static property is going to behave just about the same. I'm going to say public. I'm not going to add the static keyword. String non-static name. So this is a non-static property protecting the non-static name field variable. And I've named my field variable capitalized non-static name. This property will have a get and a set block. Again, the get defines the read access. This is the read access. What do we do if you want to read what this object's name is? Well, if you want to get the value stored inside my non-static name property, I will return the value that's actually stored in the field. So we return the field value. The property does not hold any values, it's just a pass-through. So we have to give it the value actually stored in the variable. Now what about the set block? Set defines write access. And we want to do a check again. We want to say, well, if the value coming in is not equal to an empty string, what will we do? Well, if it's not empty, we will assign it. I will say non-static name is equal to value. Here I'm assigning into the field only if the value is good. Well, what will we do otherwise? Well, we can decide to do whatever we want. We could print an error message. We could assign any value we want to. In this case, I'm going to say we'll do something, we'll call this default. I'm setting the string name default. Maybe we will call it default name. So if the outside world tries to assign an empty string into my non-static name property, we will hold in our field variable the value default name. Okay. Just to look at these two properties again, they're very similar. The only real difference is one of these properties is static to protect the static field. The other property is not static, and it is protecting the non-static field. Okay. Now, back here, we made our field variable private, so we can't see it. But if I say example dot, notice that I see the capitalized static name property now. The field, the lowercase field variable has disappeared, it's private, but this property has taken its place. So I can try to assign a value into the property, not directly into the field variable. Same with our object. Our non-static field variable is no longer accessible, but now we see access to our public property, the capitalized name. So in both of these cases, I'm trying to assign a value into the property and trying to get it into the field, but there's protection involved. So let's run this. So in both of these cases, I tried to set the name to an empty string, but our properties added protection. They intercepted that assignment. Now if I assign a good value, we'll go back and we will assign Rogers through the property, and I will assign Anna through the property. And because both of these values are not empty strings, the properties allow it. So properties allow protected access to the field variables. And our methods here are printing the field variable values. All right. Hope that makes sense.